Hi everyone. In today's challenge, we are going to solve this problem. The problem name is minimum depth of binary tree, and the problem number is 111. Alright guys, so as usual, first of all, we are going to clearly understand this problem statement. And after understanding the problem statement, we will move to the logic part. We will see how we can solve this problem. What is the logic to solve this problem? And after understanding the logic part, we will move to the implementation part. We will implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. Now let's see what this problem says, right? So let me move all these things and let's understand the problem statement. So guys, problem says given a binary tree, it find its minimum depth. So we are given first of all a binary tree, right? Binary tree is nothing but a tree which can have at max two child, right? So true child means nothing but a left child and right child. Simple, right? This is called a binary tree. So let me draw a binary tree simple so that we can understand what is depth as well. So this is nothing but I'm drawing a binary tree. Simple guys, this is nothing but a simple binary, right? You can see this circle is nothing but a node and they have at max two child, right? So here it has two child, two child, two child, and if I remove even this is also binary because at max they can have zero child as well, one child, and two child as well, right? So now what we have to do, we have to return the minimum depth, right? Simple, we have to return the minimum depth. First of all, we need to understand what is depth, right? So depth of this tree is nothing but we can say starting from the root node till the last node. How many nodes came? 1, 2, 3, and 4. So total depth is nothing but we can say depth of this binary tree. Depth of this binary tree is nothing but 4. Simple. But we don't need to return this part. Right? We don't need to return this thing. We don't need to return the depth of a binary tree. We have to return the minimum depth of a binary tree. So what is the minimum depth? See guys, we can easily understand this if depth of a binary tree is nothing but the longest node, right? So this is the starting node to the last node. So minimum depth means starting node to the nearest node where we our tree ends. So nearest node is the this one. Here our tree ends. So we can say this is the depth. It's going to be nothing but minimum depth. So here you can see only three node came, right? So answer is nothing but going to be we can say right simple minimum depth is going to be nothing but 3 only. I hope you understood now what is depth and what is minimum depth. I hope it makes sense, right? So depth of binary is nothing but 4 in this case, but minimum depth is nothing but 3 in this case. So we have to return nothing but 3, not a 4. So by this only you must have understood the we can say problem statement. But let's see the next line. Minimum depth is the number of nodes along the shortest path from the root node to the nearest leaf node. Same thing, shortest path from the root node. This is root node, right? And this is nothing but nearest leaf node. You can see we don't have any leaf node in this level except this one, right? So this is nothing but the nearest leaf node. So this is nothing but 3 only, right? Alright, so note a leaf is node with no children. You can see guys, there is no children, right? There is no left, no right. Alright, so we have seen now this. Now let's see the examples and let's try to understand from there as well. Still, if you have any kind of doubt, right? But if you understood here, you can directly skip to the logic part. I have mentioned the timeline as well, right? Alright, so now let's see here. So you guys can see that this is the first example where we have this tree. So here this is nothing but we can say the depth of binary, which is nothing but 3. But we have to find the minimum depth, so which is nothing but this one. And this is nothing but 2 only, right? So we are going to return nothing but 2 because there are two nodes exist, one root node, second is last node. Fine. And the next example we have this 3, we have 2, and after that we have null, there's no null, and there is exist 3. Fine, so we can remove this one. So let me just say this, and after that we are going to have null again, and this is 4, and after that we have again null, I guess. After 4 we have null, and this is 5, and this is right. So this is nothing but simple, this is binary. So we have this binary tree. Now we have to find a minimum depth, right? So what is the minimum depth? So this is the minimum depth, right? So we can say this is the minimum depth because this is circle, this is circle, this is circle, this is circle, and this is circle, right? So we can say how many nodes coming from this root node to the least nearest, we can say nearest leaf node. So only leaf node is nothing but 6 only, right? So we can say 2, 4, and 5, right? So there are total 5 node exist from root node to the nearest leaf node, that is 5 only. So this is the minimum depth and the actual depth as well. So we are going to return 5 only, right? I hope it makes sense. So we have seen the problem statement, we have understood what is minimum depth, what is simple depth, and how we can return this. We are going to see now logic part, how we can actually solve this problem, right? So let me just write a simple logic. So guys, this is now, let's see in this logic part how we can solve this problem, right? So I'm going to take this simple example, first example only 3, then we have 9, then we have 20, then we have 15, then we have 7, right? So this is the what we can say our tree. Now what we have to do, we have to find a minimum depth, right? So what I'm going to do, I'm going to use just simple recursion, nothing else, only recursion. And how? Let's see that. So guys, we have this root node, and I'm going to say just tell me this going to have the 1 plus minimum of left side and right side. Simple thing. And this also gonna have, but this is only valid for that is not a leaf node, right? If it is a leaf node, then we are gonna simply return one, right? So this is also not a leaf node. First of all, this is gonna call this side and this side, right? So this is leaf node, this is gonna return one, and this is gonna say no, I'm not a leaf node, I'm gonna say one plus minimum of left side and right side. And this is leaf node, this is gonna return one, and this is also gonna return one. For now, just try to understand this thing. Now let's move to the main part. So what we're gonna do, we're gonna say this is one, right? This is nothing but we can say leaf node. This is gonna leaf node. So this is gonna return one to the parent. This is also returning one to the parent. So we're gonna say one plus left side is nothing but one as well. Right side is also one as well. So which is nothing but minimum? One is only, right? One out of one, which is minimum? One only. So we can say one plus one. And total is gonna be nothing but two only, right? So this 20 says that the minimum depth till from my node is nothing but 2 only, right? To the all the subtrees 20, 15 and 7. What is the minimum depth? Minimum depth is nothing but 2 only, right? And the same thing, one this also gonna return to the, we can say parent. So this one is gonna come to this side. So this is saying 1, and this 20 is gonna return its, we can say, depth to the parent, that is nothing 2. So what is the minimum? Minimum of 1 comma 2 is nothing but 1 only, right? So 1 plus 1 is nothing but 2. So it's gonna say the minimum depth from 3 node is nothing but 2 only, and that's what we need. We need to find the minimum depth from root node, that is nothing but 2. So we are going to say answer is nothing but 2 only here. So you can see guys, answer is nothing but as well 2 only, right? So simple thing guys, what we are doing, we are just doing recursions, right? We are just saying from 3, first of all go to their child and try to find their, we can say, the node, right? Try to find their depth. So no, 9 will say my depth is nothing but 1, but 20 will say wait, let me calculate from my children. So 20 will say, okay, let me calculate from my children. So it will ask from 15 and 17, 7. So 15 will say 1 and 7 will also say 1. So 20 will say, I will take the minimum from left and right side. So both are having same. So it's going to take any one. So this take 1 and it's going to add 1 into this because 20 itself a node, right? So 1 plus 1 is 2. Now 3 will say, okay, let me calculate from left and right now because both have value now. Left have 1. So it's going to say, okay, 1 and right have 2. But I'm going to take a minimum 1. So 1 comma 2, which is the minimum? 1. So it's going to say 1 and plus 3 itself because 3 itself no. 1 plus 1 is nothing but 2. Simple thing guys. I hope you understood the scenario what we are actually doing over here. We are just saying first of all, if you are not a leaf node, then try to calculate from left side and right side and take a minimum and add 1 into this because you itself a node and pass to the parent now. This is the simple thing guys. Now there is one more case arise. What if there is a one, let me just make simple thing. What if this is a tree, right? So let me do this thing. So guys, but if this is a tree, right? They it's gonna say, okay, I'm not a leaf node, so I'm gonna calculate from minimum from left side and right side. But there is no right side exist, right? So minimum left side will say 1 because this is leaf node, right? But right side, what it will say? If there is no right side exist, so we are gonna return nothing but infinity. Are you getting this point? If there is no right side exit, so I'm going to return infinity. Even if there is no left side exit, if it is the case, there is only left right node, there is no, we can say, left node. So we are going to say infinity comma 1. So if any of the side is not exit, means even if left is not exit, even if right is not exit, so we are going to return nothing but on the place of that we are going to return nothing but infinity. Simple thing. And why we are doing this? Because infinity comma 1 always going to take a minimum 1, which is 1, right? So this was the simple logic guys. We are going to move to the implementation part now. We are going to move to the implementation and see, we are going to say how we can implement this particular problem in Python, C++, Java and JavaScript programming language, right? So let's move to the first of all Python programming language. So guys, I'm here first of all with the Python, and first of all what we are going to do, we are going to say if root is not null, right? If not root, let me say if not root, then fine. If it is root is null, so we can say if not root, let me do like this. If not root, that means we can say 0. Means if not root does not exist. So we are going to say nothing but return 0. That means nothing but even we don't have a root node as well. So how we can calculate the depth, right? So depth always going to be 0. But if root node exists, then we are going to define one function that is nothing but get min depth, right? If root node exists, so we are going to define one function root get min depth. In that function, we are going to say if our root here, if our root node exists, so this will always the case that when left side does not exist but right side exists, or right side does not exist but left side exists. So we are going to say if not root, means root does not exist, so return nothing but infinity. So we can say float infinity, right? And here if this is leaf node, if root, if not root dot left, let me say root dot left and not root dot right. If it is a leaf node, so what we can say, we can say directly return 1, right? Leaf node is always going to return 1, fine. And if we can say if not if, we can directly now return 1 plus This is nothing but a node which is not also a, we can say, empty, and which is not also a leaf node. That means this is node which have a children. So it's going to return 1 plus, take from left side and right side and take the minimum one. So we can say get min depth, and here we can say root dot left. Same thing, get min depth and root dot right. Take minimum from them, and after that add 1 into this because this is also a node, and, return the this particular value to the parent one. So all right. So now let's call this function get min depth and for root, and we can simply say return this one, right? Return this one. Now let's run this code, and I hope guys it will also gonna pass the test case, right? So you can see guys both the test case pass. So let's try to submit this code, and it is a simple problem, right? Easy level problem. So I don't think you will have any difficulty to understand this problem. But actually we were doing nothing but we just saying that from a root node, if it is not a leaf node, so calculate from the left and right side minimum and add 1 into this and pass to the parent again. If it is a leaf node, return 1. If it is not a leaf node, not a node which have a 2 children, means if it is empty node, so return infinity. Simple. Now let's move to the next programming language, which is nothing but C++. Here simply if root is null, or we can say null ptr, right? And even we can use this simple explanation, if not root, then you can directly return 0, right? But if it is the case, so let's define one function here at the top, int get min depth, right? And here we can say tree node, and it use a pointer C++. So let's give it a pointer, and here we can say if now here no root exists. So what we are going to return? We are going to return nothing but int max. But if it is if it is a leaf node, first of all check if it is a leaf node or not. Root dot left node, we can't use a dot operator here. We have to use this. If root dot left is null ptr, or we can say and, we have to use and because both should be null, right? Root dot right should also be null. So we can say if both are null ptr, that means this is a leaf node, so we can say return 1. But if it is also not a leaf node, so we are going to say return 1 plus take a minimum from get min, this min depth, and here we are going to pass root dot left and root dot right. Fine. Now we are going to simply say semicolon and call this particular function, return this particular function, return get min depth, and we are going to pass inside of that root. Now let's run this code and see whether it's working fine or not. And I hope it should work, right? So you guys can see that both the test case pass with C++ as well, and it will also going to definitely submit. So let's see that, and you can see it successfully got submitted. Now let's move to the next programming language, which is nothing but Java. And simply first of all, let's define a function only, right? We know we have to define, so why we need to waste the time? So we're going to say int get min depth, and here we're going to say tree node and root, and if root node exists, so here we can't use that operator, we have to directly root is equal to null. So we can say return nothing but integer dot, we can say max value, right? And if root dot left is null and root dot right is null, that means this leaf node, return 1. And even if it is not the case, then we have to find minimum from left and right side, return 1 plus minimum. We can't use that, we have to use math dot minimum, and we can say get min depth, and we can say root dot left get min depth, we can say root dot right. After that we can simply say call this function, but before the check if root is equal to null ptr, not ptr, this is not C++, it is equal to null, and we can simply say return 0 because there is no root node exists, so that depth will always going to be 0 only, right? And after that we can say get min depth and call for root and return whatever the value they are going to return, because at max at least there will be 1, right? Because root node exists, right? So now we are going to say run this code and see whether it's working fine or not. So you can see both the test case passed with Java as well. So let's try to submit this code as well, and definitely it will also want to submit because it is an easy level problem, right? Now let's move to the last programming language, which is nothing but JavaScript. And here we are going to say fine if root, we can say root simple is equal to undefined. So what you can say, you can simply return 0. But if it is not the case, so you are going to define one function const, let's say get min depth, and this is going to take parameter root, and here we're going to say if root, let me take a small, if root is equal to undefined, so tell me guys what we have to return. We have to return max value, we can say infinity, right? After that we can say if root left null, not null, we can say undefined, and root dot right is equal to undefined, then we can simply say return 1. But if it is also not the case, Then what we are going to do, we are going to take a minimum, return 1 plus minimum, and we can't use simple minimum, we have to use math dot minimum, right? So we can say math dot minimum, we can say root, not root, we can call this function get min depth, and we can say root dot left, same thing, get min depth, root dot right. That means root dot right. Fine. And after that we can call this function return get min depth, and we can pass a root. Now let's see whether it's working fine or not. So let's see whether it's working fine or not. And you can see guys, both the tests pass here as well. So finally it will also kind of submit it, right? So I think it will submit as well. So you can see guys, we this JavaScript implementation also got submitted, right? So we have successfully submitted with Python, C++, Java, and JavaScript. I hope you understood the implementation part, and I believe guys you understood the problem understanding part, logic part, and implementation part as well. So if you have any kind of doubt in these three sections, problem understanding, logic, and implementation, you can write in the comment section. I'm always there to help you. So that's all in this video guys. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.